All right. Happy Monday. Glad you're here. So sorry about Wednesday again. I think we'll be okay. We're going to do midterm review. We're going to talk about project two, and we're going to finish up streams. It should go pretty quick. I think is the plan. So, uh, which one do you want to do first? Sorry, what was the vote? Project two solution, midterm review, and finish up streams. You guys are bad at consensus here. I got to vote for midterm, vote for project two. This is due today, right? Project two, 23rd. I put 11:59 p.m. Oh crap. Okay. Well, let's not go over that yet. Shoot, did I not change? Okay, should have been at 11. That's my bad. I'll post a video of it then tonight for you. You don't want to come Wednesday just for that. That's real boring. We could. Okay. Let's. Okay. Let's spend just a minute here on this.
Uh, so I have it where it's too early and I'm not able to
You
figure
want
out
some
where it's
coffee?
the spaces or whatever, filling in the letters there. Let's say four letter word is rage. If you guess A, it puts the A in the right spot. And then if you guess G, doesn't keep the A, it puts the G in the spot. So I'm trying to figure out how to make it like keep the previous letter. Yeah, right. Oh, okay. Take it out. That makes sense. Yeah. I sat there for like a day until my eyes were like burning from staring at the screen like, come on, this has gotta work. No. The stuff leading up was not that difficult. Currently I also have it written to where it does call on like there's six functions. It calls on like four or five of them. But then the rest of it, I think the last two, like what is it? Has the word been guessed and is or has the word been guessed and then has the person been hanged. I haven't made those two into functions because I couldn't figure out how to uh guess get those to work. So those are currently uh not crossed out, but they're green with the two forward slashes. Uh
Commented? Yeah, we'll take a look at some of these here because I gave you like a little bit of garbage here, but that's okay. We can make this work. So it's kind of fleshing out the rest of these functions here. Straight this. And let's sure. It's not guessed. Hidden word. We're almost there. Guessed. Yes, string for hidden word. Sorry for all the underscores here. I'm just, it was already there and I don't want to change it. Oh, yeah, I was missing the number of things here. And this actually should be a not. That's my mistake. And then a print gallows. We're almost there. Print gallows and got this one up here. Oh, that one okay. We've got to be consistent here. You got to pick a style. You got to stick with the style. Incorrect guesses. All right. So these are the functions we were writing. Right? Our get word, for now, I'm just going to put test, like, just going to stub it out. So there's something here, we can go back and fix it later, right? If you want to be cute, you can say to do, fix me, or something like that. You can leave yourself comments. That's fine. There's actually some built-in tooling around the to do or fix me, but that's okay. Um, all of them need to be fixed, obviously, here. Has the person been hanged? We'll just say return false. I just want this to compile here, right? It's sort of the idea. Display the hidden word. This is void, so nothing has to happen. This one's a char here, so we're just going to return, how about the letter A to start? We can always come back later. Is the letter guessed in the hidden word? We're going to return false to start, and then print the gallows. Again, it's a void method, so we don't, a void function, we don't have to do anything here. So this is the sort of loop here. So I've got my string for the numbers, the letters I've guessed. I've got my hidden word that I'm getting. I've got my number of incorrect guesses. And as long as we have not guessed the hidden word and we've not been hanged. So that's a little long, so I can bump that down, right? So probably works better on your screen when you're not zoomed in. We'll display the hidden word, given the hidden word and the letters guessed. We'll get the new guess, right? Get the letter guessed, a singular letter character here. Now, if you change the letters guessed and add to it, right? Because strings are mutable, we can do that depending on how you write your functions, or you could just come back and take your letters guessed and you could add the guess to it here, right? Either way you want to do it here is fine. Just right, if you want to make your string mutable, make sure we're passing by reference. Either one was okay, right? You have options, so either approach, right? Either add the letter or update the letters guessed. Can't spell in the function, right? Either of those should work, right? And then if it's not in the hidden word, I missed the not here. I'm sorry. Hopefully you caught that as you're looking through the demo. If it's not there, it's an incorrect guess, right? And that's just a singular guess. And then we print the gallows every time, right? Display the hidden word, get their guess, and we repeat here. So to get the word, I think this one's pretty straightforward, right? You ask them to input a word, check the size. If it's not four or more, keep on asking. Right? Those sort of validation loops we've done. Has the word been guessed? It's a little bit trickier, still not too bad here. So we're looping through the strings, right? We're looping through the hidden word, making sure every letter has been guessed. If you find a letter that has not been guessed in the hidden word, that's not in your letters guessed, you obviously haven't guessed the hidden word. You can just return false. If you've checked every single letter in the hidden word and you haven't returned a false, you can probably return a true, right? So it's inside the loop, right? It's a loop of the loop. As you loop through every letter in the hidden word, loop through all the letters and letters guessed, you can either, yes, we found it, which is good, or as soon as we don't find one, return false. Right? So you want to find what's the way to shortcut this here, that logic, right? So we can loop through for every letter in the hidden word, check every letter in the letters guessed. If it's not there, return false. Right? At the end, um, and you haven't returned false, false. Return true. Right? That's sort of the logic. We're just kind of, can we do this by not paper, I guess, pen and paper? Like, can we talk through it? Can we get the English version down? That's what we want to be able to do first. So some people like doing comments. That's fantastic. Like, just leave some comments of what you want your steps to be, and then go turn that into code. That's great. Um, Generally, I just kind of talk and do that as I go. So I don't usually leave the comments there. This is a little bit different. I'll commit this to the repo for later if you want. So for has the person been hanged? This is a pretty quick one, right? So that you get a certain number of incorrect guesses before you're hanged, right? So I think that's a pretty straightforward check. For displaying the hidden word. Now this one is again a little bit trickier, right? For every letter in the hidden word, right? Every in the hidden word, if it's been guessed, print the letter. If it hasn't been guessed, print an underscore, right? Print the blank. Now that sounds a little easier than it actually is, but as we loop through every letter in the hidden word, then we have to go look at every letter in letters guessed, right? But you don't want to print inside that loop, right? You want after you've looked at every letter that you've guessed, you have guessed it or you've not guessed it. So you're not doing a lot of things inside the second loop, the inner loop. Does that make sense? This is where I think a lot of people were stuck, right? So if we just said, for every letter in hidden word, and then this was some sort of loop here, right? We're going to pretend it was a loop here. And then for every letter in letters guessed, right? Here's like, pretend that's another loop here. And then what do we say? The letter matches. What do we do if the letter matches? I'm sorry? Well, if we print it here, bad thing's going to happen. Well, you don't want to do that because the hidden word it already is the word. The hidden word doesn't have any blanks in it. We're either printing a blank or printing the letter. We don't need to keep a bunch of underscores around and replace them. That gets harder than it needs to be, right? And do the least amount of work possible. So if the letter matches, we're not printing right away, right? Just mark that it has been matched, right? All you want to do is say you've been matched, right? When that loop is done, then, right, for every letter and letters guessed, then we can go and do something, right? If the letter matched, then we print the letter. Otherwise, print the underscore, right? So the location where you put this matters because this is for every letter in the hidden word, not for every letter in the letters guessed, right? This one has to end first. Then we've either found it or we didn't find it. Then we can print the letter of the space. So depending where you put it inside this loop will make a big difference.
If you need like another way for the and I call it like lumps or something. And you look from the size of it or it turns out matching. Then you run this loop and if it matches, you replace
You don't replace anything. That's more work than you need to do.
not in hidden word in move
You don't want to do that. That's a bunch of work. All we're doing is outputting, right?
to hidden word.
And you could, but you don't. It's harder to make new variables and track new things. Like all we're doing is either printing the letter or printing a space. That's what it comes down to for every letter in the hidden word. Right? That's off by one. Right, so this one ends this one. So for every letter in the hidden word, you either print the letter or you print a space. That's the simple piece. Right? You can definitely do it and make new variables and sub things in and start with underscores, and that's really awkward. Right?
I actually kind of like that.
Yeah, I mean it can work for sure. Uh, I would argue this is simpler, but again, it's more than one way to do something for sure.
I really with the way.
Yeah, you can add more variables. Yeah, right. The get a letter guessed based on the letters guessed. Right, we don't allow repeats. So this is get the letter, make sure it's one letter, right, and then check to make sure it's not in the letters guessed. Right, get a guess. It's one letter. Sure, it's not in the letters guessed. Yes. Right. And we just keep them in there. If it's in the letters guessed, we have to keep on asking it. So this is actually slightly trickier than it sounds. Because keeping them in a loop here, if they've guessed the letter or not, takes a little bit of work with the loop, right? Because we have to prompt them again, and then we have to check every single letter again. We have to prompt them again, and we have to check every single letter again. You can't just check every letter and then prompt in the middle of that check, right? And then is the letter guessed in the hidden word? This one's pretty straightforward, right? We're just checking every letter in hidden word. Every letter in hidden word. Let's see if it matches the letter guessed. Matches letter guessed. Right? This is a single loop. Again, this one, right? If you find it, we can return true. And then if we haven't returned true, we can return false. Right? As soon as you find if it's there, you can return true. Right? So for every letter in letters guessed, or in hidden word, right? We do this sort of thing. If we find it, return true. That's it. That's what happens inside the loop. Right? If we didn't return true, then we just return false because I didn't find it. By the time I've looked at every letter in hidden word, if I didn't return a true, right, my function didn't stop, I can just give you back false. I didn't find it. And then print the gallows. This is just variations on printing this. It's as ugly. I'm sorry. But that's what it is. It's not the end of the world. This will go pretty quick, right? And when you have backslashes, right, you have to escape your backslash for this little foot here. That's all, right? Okay, does that help with the project?
Like the way I was thinking of it is every scholarship had to be returning something, and so that's how I was confusing
Uh,
myself. I forgot to do bullets and booleans.
you could return the gallows as a string if you wanted,
Yeah,
and
and then
then
the
display the hidden word. You could return it as a string and do this variable substitution thing.
yeah, that's the one that I
Yeah, that could work.
did that. And then get word is also obviously returning the word that,
Yeah, yeah. Get
but
word will return a
I
string.
didn't need to use a bool or a void for has the word been guessed or uh,
Yeah, booleans are very handy. All right. So 11:59 p.m. because that's what I put in Canvas. My bad. But you get some extra time. All right. So we commit that as like a little further dive into that, and just with some comments, right? A little more starter code project two.
question on the uh, review for the midterm questions.
Yeah.
They had vectors and arrays in it.
Yeah, we didn't get to that yet.
Okay.
So, but that's the like size question. It'll be that short. Is that the question?
Your algebra, access the correct answer.
Yeah, I'm going to go over it.
Oh.
Yep. Does someone else have a question? Yeah.
We're taking the exam here, right?
No. I mean, you're welcome to. Uh, I I don't recommend it, but you can. So on Wednesday, 11 p.m. or 11 a.m. The midterm will open. You'll have up until next Monday, 11 a.m. to take it. Whatever time you like taking tests, go for it. It will be timed though. So once you hit start, you'll have the same hour 15 as if we were taking it at 11 a.m. to finish it. So whatever time you like throughout the week, hit start, sit down for an hour 15, take it, and turn it in. Right? Yeah, it's in Canvas. Yeah, it'll be a Canvas quiz. So I'll load it up later today, probably. Um, so this was the sample one. Hopefully you saw that pop up in files. Yeah,
We're gonna have to submit anything to GitHub or
I'll just ask you to. So copy paste is probably easiest for this because it's pretty small snippets. Yeah, and that's probably the easiest way to do it. GitHub would be nice, but then like it gets weird sometimes. So uh, yeah, so like the coding questions are here's a smallish sort of thing here, and this one has vectors. We didn't get to vectors yet. That's okay. But this size question here, like do something. This is so ideally this takes you about 10 minutes or so for this. If it takes you 15, 20, that's okay.
So the only first was like,
No, no. So we didn't get there yet. So we had the content schedule was ahead a little bit last time I taught it. So, um, but this is the size question. You'll see. So write a function that does something here. Check do something, right? Whatever it is, do something. Step return something. Right. And then another one here. Again, we're not doing vectors, but this idea of testing it. Does it do what it's supposed to do? How do I know if it's right? We haven't got to unit tests yet. That's okay. But it's a pretty short. Let's do a small thing here, right? To be another function, um, and then another function. So again, we were going to do a question on streams, a question on functions, and a question on loops, right? So the question on functions might also have a loop in it, right? But one that's just write a loop that does something, right? One that do something with a file stream, and then one maybe even a string, probably not string streams because those are just annoying. And then one on a function, probably takes some parameters, probably returns values, those sorts of interesting things here. Um, yeah, that got real small here. Sorry. And then these are all like true false. Now, what I'd like to do with my true false questions, because I find them more interesting than just boring true false questions, is if it's false, you have to correct the statement. So you can't just say false. You have to say, how do you turn this statement into a true statement? Um, so, and you get a free point just by acknowledging the academic integrity policy. Someone actually did a research study on this, which is really interesting, and they published it. And we do all sorts of silly things in academia, uh, but they found there's a difference between asking at the start of the exam and asking at the end of the exam. They like did the test. They had human studies subjects come in and they do all sorts of stuff, and I don't know what they were telling me they were doing, but they found if you ask them at the beginning of the test, they're more likely to actually abide by the policy because they've agreed to it beforehand. Versus you go through the whole test and you may or may not have cheated, and then at the bottom they're like, "Hey, by the way, you're not allowed to cheat on the test." Like some people are like, "Oh, I already cheated, but I'm going to say yes anyway." So by asking you first, you're more likely to say, "Oh, yeah, okay, I get it. I won't cheat on this." And people are actually pretty honest um, if you tell them ahead of time. If you ask them at the end, they're less honest. It's a little weird, but that's okay. Um, and another fun study, just because it's interesting here, when people are cheating and being honest in these sorts of things, they had people come in. I forget what school, but pretend it's U of M and Ohio State. People would come in with like jerseys and swag and all sorts of colors on it, things, and they would ask a question, and if you answered the question, you could, or no, so you would, they gave you a test, and you go up and say how many you got right. There's like a self-graded test, and then they would pay you based on every correct answer. And they had people in Michigan jerseys, assume we were Michigan fans, in Michigan jerseys, go up and say, "Oh, I got 15 out of 15 right after like 2 minutes on a math exam." And they're like, "Okay, here's your $15." And like a bunch of people did it who were plants. And then the actual survey subject people are like, "Oh, wait, I can get away with cheating. It's okay. I'll go do it." And they did it. And then they ran the study again, and they had the people in Ohio State jerseys go up and cheat and say, "Oh, I got 15 out of 15 right." And all the U of M fans did not cheat. It was like, "Ooh, the dirty Ohio State people are cheating. We're going to be better than them." So this sort of like group think is really interesting. So if the people that you respect don't cheat, you also don't cheat. If the people that you despise and the dirty Ohio State fans cheat, you're like, "Oh no, we're going to be better than them because we're U of M. Obviously, we're better. We're not going to cheat because they're the bunch of cheaters." So like you can influence behavior in really weird ways. But asking people ahead of time not to cheat is a good thing. We're all going to agree not to cheat, and that way I can keep giving exams like this because I hate watching people take tests. And 11 a.m. is a terrible time to take a test unless you're a morning person or have had like a pot of coffee. So this thing fits. It's an entire pot, and then some. It's amazing. I love it. And then at night, it's also a growler for beer. Is that a question? Uh, most of the time, it's plagiarism, right? You're turning in someone else's work without putting your name on it or without crediting them. So everything you turn in, I assume, is your original work, unless it's otherwise cited. That's what we do in college. Unless you cite your source, we assume it's yours, right? So if you give me something that's not yours and you didn't cite it, that's plagiarism, a violation of our policy. You fail the class, right? It's not hard not to cheat, I promise. Like it's not a hard test, right? And if you look something up, go for it. Just cite your source. Say, "Hey, I found it here." That's perfectly fine.
Like Stack Overflow or whatever.
Sure, yeah. Just give me the URL. Say, "Hey, I got found it here." That's awesome.
Open book.
Yeah,
So
it's open book.
side books is
Yeah. So
Wasn't this like something we have mentioned for books and what is more
I'm sorry.
if we have events, what is it for our culture is more or research it's of use to use.
I mean, so if you're giving me an answer that you found online, you should cite the source, right? If we've done it in Zybooks, we've done it in class, and you just have it in your head, that's great. I don't expect you to have to go back to Zybooks and say this specific section is where we learned that. That's okay. But like, if you're actively going and finding it, then cite your source, right? Because you went and found it. If it's in your head, that's fine. Anything we've talked about in class, anything for the Zybooks, I assume, hopefully, is probably somewhere in your head, or at least you can go find. So if you have to go find it, just give me your source. Um, so like, true or false? Variable names should be short and use abbreviations whenever possible. That one's false. So how do we correct it to make it true? Yeah, variable names should be descriptive and use full words whenever possible. Sure, that's great. So I love that you didn't just put not, which is technically true, like to correct the statement. They should not be short and use abbreviation. But the spirit of the question, right? Give me a good true statement here. So I appreciate that. When you divide a double by an integer, you will get a double type result. Awesome. Given the code, how many code blocks will execute in a single run of the program? So I get a great, sorry, that's a little slow. Can I zoom this in? I can zoom in. I have the zoom power here, right? How many of these code blocks, right? The blocks of these set of parentheses, curly braces, make a code block. So this one's a little tricky. Does it have to be one? It's definitely not all of them, but is it always one? Is there an else?
Could be 0.
It could be zero. So 0 or 1 is the correct answer there. Right? If you just say 1, it's probably 1, but it could be 0. Right? So that's the catch there, right? Like, so 0 or 1 is the most proper here, right? Maybe none of them run. There is no default. If there's a default, just that last else, then definitely 1. If there's no default, then maybe 1, maybe not, right? Um, when comparing strings for equality, C++ is case sensitive, true or false? True. Yeah, we're case sensitive. The string variable type can be thought of as a blank of characters. Sequence, I like that. You could also use the word string, a string of characters, if you'd like to be repetitive. Yeah, easy. A while loop will run until something in more than one word, right? Is ideal for this blank.
Conditions are meant to be
Yeah, the condition is no longer true.
Body.
Well, so once the body ends, it goes back up to the condition and checks the condition. So it runs until the condition is no longer true, right? Or yeah, I think so. Specifically about the condition is more specific for this one. Yep. True or false? It is impossible to make an infinite loop when using a for loop. That is false. So what is a correct statement there?
It's possible if you mess it up that badly.
Yeah, sure. It is possible to make an infinite loop. Definitely. So be careful when you do your plus plus or minus minus or greater thans or less thans, right? Uh, you can mess it up. Or the really fun infinite for loop, right? Because they're all optional. I got an infinite loop now.
That's it.
It's real ugly to do this though. Don't do this, please. Right? Just don't. But yeah. What are two reasons for using functions? Just in English.
With the program.
Hmm?
Makes it easier to read.
Yeah. It makes it easier because we put names to what's happening
You know,
and avoid repeated code. Yeah, so you don't feel bad about yourself. Bonus points if you say so you don't feel bad about yourself. Any other reasons we use functions?
I guess shorten your main function.
Sure. Yeah, makes main a little easier to swallow there. What about functional decomposition? Break a big problem down into small problems. It's easier to solve small problems. I'm sure you found that with Hangman, right? It's easier to solve these small problems. Sort of is, right? Then instead of just here's Hangman, do it. If I did that, I assume most people would just go online and Google Hangman solutions in C++, right? Is that fair?
I mean, I looked at the best ASCII art for that section, but
What does the variable's scope determine?
the type of variable.
No, so this is scope. It's not
where
type.
it is in main,
It doesn't always have to be in main,
where
remember?
it is within the program.
So where it is determines its scope. But what does scope determine?
Where it's accessible.
Yeah, where you can use it. Where is it accessible? If you declare it inside a main, you can use it in main. If you declare it in a function, you can use it in a function. If you declare it inside of a while block, you can't use it outside that while block, right? So the scope determines where you can use it, where it's accessible, right? I think where it is sort of there, like it's halfway there. Yep. So that's where it is, but where you can use it more. Uh, what is unit testing? We didn't get to that yet. It's okay. Um, True or false? When passing arguments to a function, they're passed by reference by default. It's a lot of by's there. I'm sorry. Do we pass things by reference by default or by value by default? By value. Yeah. So value is the default. If you want to pass by reference, you have to add your ampersand. I gave you the true statement there. Shoot.
Wasn't there a pass by or a third pass by reference value a? Because I looked inside for this answer.
You can pass pointers, but we haven't got there yet
Okay.
either. And that's probably the third option, which are technically a reference. Pointers are the worst. They're awful. I mean, they're great. They're really good. True or false? Arrays. Oh, we didn't get to arrays yet. That's fine. We didn't get to vectors yet. We didn't get to vectors yet. Okay. So does that make sense? So ideally, these are pretty quick questions, right? Maybe a minute each. if you're taking 2, 3, 4, 5 minutes because you have to go look it up, getting through 15 of them might take you a little while. So half of them you want to look up, sure. A third of them you want to look up, that's okay. But if you look up all 15, you're probably going to run out of time. That sort of thing. So, go through, give it your best guess, and then come to the other ones. So each of those are worth a point, and then the long answer questions are worth 5 points each. So 30 points total, right? So half of them are the three long answer questions, half of the quick quiz style questions. Uh, will make up your 30 points on the midterm for that. So, uh, and again, on these long answer questions, you got to give me something, even if you don't know the whole thing. So if you give me something, I can give partial points on your loop, on your streams, and on your functions question. Give me something, even if you got nothing. You got to have more than just a little bit of nothing. So just flesh something out, even if it's just some, here's some. It's going to do something. This is what I think it's going to do in English. Sure, I can give you partial points at least there. So better than turning in blanks. People turn in blanks, and I get real confused sometimes. It's like someone turned in a blank all three questions were blank, and they only spent like 20 minutes on it one time. Like they had a real bad day or something. Like didn't even try. Like you had time to give me something. I don't know. So, um, but yeah, that's the goal for the midterm. So you should be able to take it easily in an hour 15. If you need the whole hour 15, fantastic. That's fine. You have it. No worries there. So take it at your leisure, whatever time you prefer, as long as you get in before 11 the following Monday. Right. So whenever you like to take tests, hit start, and please don't work with each other on it. That ruins the whole. I can make this flexible and easy for you folks. You don't have to take exams at 11 a.m. kind of thing here. Okay. All right. We good there? Back to streams then. And then we'll finish up our streams here. It's the wrong book. It says being off by one number is really annoying. There we go. Let me go. This one. Did I change it? What did I do? Did I not hit save before? Yes. It shows a bunch of green stuff here. I thought I committed this already. Maybe I didn't commit. You started? I must not have actually hit save. All right, chapter 6 streams. Did that work? Yeah, that worked. Okay. Excuse me. So we were reading files with our stream so far, and input streams if you so chose to read strings as streams. Too many S. It's like reading a Dr. Seuss book. So now we're going to look at how we will write files, which is super exciting. So then we can write a file and keep it around. And ideally, like if you write a file, you might also want to read it later. Right? If you want to read a file, to read it in, and maybe you're going to write to it later, that sort of thing. So a lot of times the format of input and output files are going to go hand in hand because if we know how we want to write it, I know how I can read it. Or if I know how I want to read it, I know how I want to write it. Whichever one we want to start with, as this is how we're going to put data in a file, that's what we're going to work with. So if we, instead of printing all this stuff out every time, right, so I think we had that little table we built here with just a bunch of numbers. Sure. Or the starting on the outs, right? We did 5%, why not for 30 years, 100, right? So this sort of output here, if we wanted to spit this out in a file, we could, and then we'd have to do the, read an int and then read things and read an int and read a double, read an int, read a double. We could do that. So if we want this format for reading, we can write in this format. If we want a different format for reading, then we write it in a different format. That sort of idea. So I'm just going to open up their example here because it's easiest here. So this is file output. So when we write to files, again, we're going to open the file, we'll write to it, and then we'll close it. Just like we did input file. We open the file, we read it, and we closed it. Same process, but now instead of read, we write. So you will go and open a OF stream, and then you give it the name of the file. We make sure it does open. Right? Just like when we read a file, we make sure we did read it successfully, it opened successfully, and we can do something. So instead of using cout, we're going to use our insertion operator. We're going to insert into the stream. Seems a little funny, but you're putting it into the file, right? And then when we're done, we close it. That's all it is. So if we wanted to do that instead of, so we did our string. I can't even say that right. If we wanted to change that, let's see, we did Yeah, there was our table. So the table was one giant string here. This was not, yeah, sure, and we could do something with that string. Uh, if we wanted to write to a file as we were going, we could do that. So let's change this up here. And let's say instead of writing this to a file, instead of outputting it to a string stream, let's output it to a file. So we're going to have an OF stream here. So this is my OF stream. It's my output file stream. Uh, this is my, I don't know, output file. And then my output file dot open. Right, we're going to open it. And what are we going to call this? How about retirement dot txt? Again, the txt is optional. Windows doesn't need, or Mac doesn't need file extensions. They're just helpful because then Windows is like, oh, it's a text file. I know what to do with it. So if you add txt, it expects it to be a text file. So we probably always want them. They are optional if you want to get particular here. And then, hey, if my output file is open, if it's not is open, right? Something bad happened. Let's return one. Just, yeah, it's error. Bad thing happened. Oh shoot, you can't return a one here. Error. We'll just return error because this is in a string function. It's a little messy, but that's okay. We'll just return an error. Okay. So assuming it did open, then right, we didn't return. We can keep on going. So let's take our output file then, and every time we do our output string stream, we're going to just replace that with this. So we've wrote all the things, and then when we're done here, we'll take our output file and we'll close it, and then we'll just return. Please see retirement.txt. Right? Sure. Right. We'll tell them to go open the file. So just like we were couting or using the string streams to set stuff, we can send stuff to the output file and set it's a stream. We can send stuff to it. We give it a run for $100, 5% rate, 30 years or 35 years, right? No, even longer, right? You're going to be 70. So that's 40 years. 50 years. It was 50 years, right? From 20 to 70. And you got 50 years of work ahead of you. That's awesome. Super exciting, right? $100 a month. Please see retirement.txt. Sure. Happy Monday. Okay. Why not? What was going on there? We'll just kill it. I forget what happened next. And let's go see what's in our folder. So it didn't add it right away here, but I think it should be out here. Let's go open this in File Explorer. Yeah, here's retirement.txt. So we didn't add it to the project. Remember, this is the Solution Explorer. Solution Explorer shows us stuff that we've told Visual Studio we want in the solution. It's not a folder viewer, right? We don't have a folder named source. We don't have a folder named header. This is the solution organization of it here, not a file and folder view, right? Just to expect that to be a little bit different. If you want the file and folder view, I think it's one of these buttons here. Does it show all files? Here, show all files. Here. It's showing me all the things. This is the file view now, not the solution view. I generally don't like the file view. That's just me, because I want to see what's in the solution. So usually I just leave it as solution view. Okay, but if you like to see it there, go for it. So here's retirement.txt, and it should have all the things we spit out on the screen before. Right? Not too shabby. So was that 268,000 after 50 years for $100 a month? Not nothing. It's not huge, but not nothing for sure. Right? We looked at, was it 50 years worth of $1,200? The math worked out at some point, right? That 5% return's awesome. Okay. So output files are not too bad. We open them, we make sure they actually opened, right? We write to them, and then we close them. So the problem we're going to run into, right, is how do we format things for reading later? Or how do we want to, if we know how we want to read the file, then we format our output to look this certain way. So if we were to write another program, so let me just start up another one here. Project. So this is more chapter 6, output files. Sure. And let me go steal all that. What did I do? Okay, all the red went away. That's fun. Sure, why not? Let me go take all the stuff in the header here. I can't even see it. There we go. I want all this. There we go. we'll take all of our inputs here, includes here that we needed. Okay. So if I want to write a file with like a shopping list, right? We could do that. So the shopping list probably has the item and the number that we want, right? Is that probably what we'd have? Right? So I want to buy 5 bananas. I want to buy 2 loaves of bread. I want to buy 2 jars of peanut butter. You should see my shopping list of 7 kids. It's crazy. So it's a lot of fun. So thinking about how we want the format to look like, right? If you want to make your own text file by hand, that's sort of a nice way to start to think about what this might look like here. So I can just open up Notepad. Look at that. I even had tournament open. I open a new tab here. So if I were to say, hey, I want bananas 5, or is it like 5 bananas and like 2 bread, right? Loaves of bread, right? However we want to format this, right? Now, we're probably thinking if you have spaces in here, we can't just read very easily. This gets to be a little awkward. So um, getting one line at a time out of our file, we can, but then we have to take an integer out. Like we'd have to do the string streams and take an int out and then take the rest of the string out. It gets a little awkward. So right off the bat, when I see this, I'm thinking this might be a weird format for reading. So an easier format might be to say, hey, I want 5 on one line and then the thing on the next line. And then I want a number on one line and then I want the next thing on the next line, right? Now, the problem I'm going to run into is I can read a file till it's empty. We said, okay, let's just read until we can no longer read a file. We can do that. But what am I going to do with all these things? Am I just going to throw them in a string? For now, I probably could. We haven't got to arrays yet, so we could just throw them in a string, right? Will I know how many items? I guess I could count how many items I've read, that sort of thing. Or if we know how many items are in my shopping list, we could start the file off with that. We could say, hey, this is 10 items in the shopping list, and then I'll have 10 sets here, right? 1 jar of peanut butter, I don't know, 2 apples, I'm just, oops, apples here, right? And on and on. Well, that's 1, 2, 3, that's 4 items. Right? I could say, hey, there's going to be 4 items in this file, and then my loop would know to expect 4 items if I wanted to go that way, right? And then I could go and know that I should be reading these 4 items out. So we've got options, right? Anything that we want to put in the file, we can, because we're the ones who are going to write it. We're just kind of brainstorming, how do I want to put stuff in this file here, right? If instead of if I didn't want a shopping list, if I wanted to say, hey, here's your scores. If I wanted to make like a little gradebook file, and I say, hey, I've got 30 students maybe, and then maybe I'll have a student name, and then maybe I'll have test 1, and maybe I'll have project 1, and then project 2 score, these sorts of things, right? Any sort of format I want, I can come up with. It's up to me, right? But I want to plan for reading and writing, however we want to go about this, right? Or maybe I just have student name and letter grade, A, right? Student name and B, student. This is probably not as flexible. It'd be nicer to have the scores, but whatever I want to do with my data, I can plan for this way. So let's try the students, right? So we'll have um, how about a function here? We'll just call this a void function. This is, I don't know, print student data. So to print the student data, right, I need what do I need? So I need probably the string for the student name. I gotta use. Did I not include? I did include a string. Oh, I didn't use the namespace. Using namespace standard. There we go. I probably then need what there int for project 1 score and int for project 2 score. That's probably enough for now, right? So we can do something with the student data and go and print it. Right? Okay. So I need the file that I'm going to write it to. So maybe I'll call that gradebook so I can make a file. So my OF stream, this is my output file. And I'm going to open it. So OF stream, open, call it gradebook.txt. And then if my, nope, sorry, output file. Fine. If my output file is open, right? If it's not is open, I always forget to do the not first. If it didn't open, I'll see out, enable open file. I don't know, some sort of error here. Otherwise, nope, goodness, that's an L. Then we can go and write to the file here. So I'll take my output file, and I just stream to it, right? I just insert right into it here. So we'll take the student name for one line, and then I'll take my output file, and then we'll take the project score. Sure, right? All I need is the score. If I want to label it, I can label it if I care to, but if I just want that, that's fine. Output file, project 2 score, and line. And then when we're done, close the file, right? Output file.close. Cool. So we can use that function then, print student data. Eric got 100 and 100, of course, because I wrote them. That's all we do. So this should make a file called gradebook. And there's no output here. We're just writing to files. So we're not going to see any. If you want to put stuff on the console, great. If you don't want to, great. Right? If we're dealing with files, we just read and write files. This is why the, hey, it stops here is going to be less useful as we continue on, because we're not always going to be put stuff out on the screen. We don't need to see it all the time. Just press any key and then open this up in Explorer. And I should have a gradebook file. It has Eric, 100, 100. Cool. So we got that, but that's only for one student, right? I want to do this for a bunch of students. Now, it'd be kind of annoying to do this. Let's do it again here. Let's print student data. Let's add Jeb. I'm trying to get him to take my classes. Like we homeschool, but he doesn't love coding, and it breaks my heart. Jeb, if you're listening, you make me sad. He doesn't listen to the YouTube. Well, it's okay. I didn't actually make him feel bad. Um, let's try this. So we'll see if we can print both of us to the file. Come back here, open our file. Uh-oh, I'm gone. Well, that's no good. So when you open a file, this is real dangerous here. Danger Robinson. You guys old enough to know that reference? Some of you? Oh, when you shake your head no, it makes me feel so old.
There was also a Netflix like remake of.
Oh, okay. So this was actually old when I was a kid too. At least I knew the quote. Interestingly, they think that how we like to communicate with memes, is that just a millennial thing? Do you guys do that too? Gen Z does memes?
All the generations. My mom's.
Oh wow. So they're afraid as we start to communicate with memes more and more and more that if you don't know the reference, the meme isn't going to make sense anymore. And then we'll just like have these pictures and you'll just kind of know the picture's supposed to mean this thing, but you don't get the reference, and it's going to dumb down our communication dumber than it already is because we send memes back and forth to each other. But okay, so this is from a movie. This was a robot. Robots are cool. All right, so when you open a file here, opening a file will overwrite it. So if it exists, you've blown it away. If it didn't exist, it made a new file. That's good, right? We like that it made a new file if it didn't exist. But if the file existed already, we've now erased it. You might not want to do that all the time. Bless you. Right, depending on what we want to do. So we have options for when we go and write a file here. Look at that. We can write our own HTML file. This is what you want to do with C++. You can definitely do this. Write HTML files and open up web pages because this is fun. Sure. Saving retirement program data. I love it. Look, we like stole their example here. All right. Our insertion operators. Oh, I don't want that one. Where'd it go? Overloading extractions. Extending scene. No, where is it? Where's our? Oh my goodness, why is it not there? This plus then file pen mode pen text. Yeah, I thought it was here. Okay, so when you go to open, I don't know why the book didn't have this. I'm sorry. I thought it used to. If you don't want to overwrite your file, you want to append to it, keep on adding to the end, you can specify and say, hey, please do this pend mode app because they don't write out their words that make me sad, but that's okay. So when you call open, we'll say, hey, please do this in append mode. So when we open the gradebook, we'll say input, output, stream, base, append. It's a little flag that's given here. So this is actually the number 8. The number 8 is really awkward to remember here. So we have a constant that we can use, right? Because putting names to things with constants is useful. So you could just give it the number 8. No one's going to remember what that is, right? And we're going to cite our source because we're good people, right? So now when I run my program, it should not overwrite my file if we did everything right. Let's see. And now I get Well, Jeb was already there, so it appended Eric, and then it appended Jeb. So now we're appending to the file, which is pretty useful, right? I don't want to blow it away every time necessarily, right? Or maybe you could even ask your user, hey, do you want to overwrite the file? Right? You could do that. You have options here, whether or not you want to overwrite it or not. We can ask them, right? However they want to do it. So to go and, oh, look at that. We have all these tabs open. That's fun. Love Notepad. So if you want to then go and read this file, right? We can go and read the same file here. So let's call, I don't know, how about read student data? So to read the student data, how about we give it a string for the file name? Maybe tell it what's the name of the file they should go read. Right, we can do that. So to read this out, right, I'm just going to go copy paste because honestly, remembering stuff is a little tricky right now. Let's go V1. No, 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 no. V1. Oh my goodness. Clicking the right button is also tricky. V1 GitHub. Streams. Streams. Here we go. So we're going to go and open our file, right? Make an input file stream, check if it's open or not, and do something here. There we go. So instead of opening test.txt, I'm going to open file name. Right? They gave me a string when they call this function. That's a string. I can give it a string. I don't have to have that literal string hard-coded in here. I can ask the user if I want, hey, what gradebook do you want to open? And maybe I have one for CIS 150, maybe I have one for CIS 1501. Wouldn't that be nice to like have different gradebooks? Should do that. Maybe I'm onto something, right? If it's open, great. And again, we don't need this. We're in a function, so that's fine here. We'll just check if it's open or not. And then else. Now we can start reading it out. So the first thing I read out, I expect to be the name, right? The next thing I expect to read out is the project score, and then the second project score. Right? So I'm going to read a couple different things out. So I'll have a string for name, I'll have an int for project 1 score, and I'll have an int for project 2 score, right? And then I can do my loop, right? While I've not reached the end of file here, or while I'm inputting, I guess, right? While my input file stream. Now, this isn't going to work, right? To just read one thing and while one thing and while one thing. It's a little awkward here. So we'll try name. Let's try project 1 score. We'll try project 2 score. And then we can output name and output uh, project 1 score or a dash. I don't know. What do we want to put here, right? Project 1 score and the project 1 score. And then project 2 score. Let's bump this down a line here. 2 score. Project 2 score. And then in that line, right? So we'll do maybe just one line to the console per person here. When we're done, we'll take our input file stream and we'll close it. Right, so read it all, close it, read it all, close it. So we should be able to then read student data given gradebook.txt. Right, that's the file name. Right? Let's give it a run. So Jeb, Eric, because we keep on appending here, right? Every time I hit run, it's going to keep on appending. And we get our scores back out. So if I know what the format is that I wrote it, I know how to read it. Or if I know how I want to read it, I will write it that way. So when we do our next project and we have to output stuff to a file or read stuff from a file, like read and write things so we can save data, we'd have to know what format we want so we can read it back in. That part makes sense? So for lab today, we'll practice writing files and also reading them after we write them, because that's really when it's useful. It's just writing stuff to a text file. If you're not going to read it again later, it's kind of boring, right? So we're going to do both, right? We did the reading last time, and now we'll do writing and reading for today in lab. Okay. The last little bit, this crazy stuff here is super cool. This overloading your stream operator. So if you want, and again, we haven't even got to classes here, so this is super weird. We can come back to this later when we get to classes, but you can write a function that takes this operator, stream insertion operator, and does something with it. So the function here, again, is not going to make a whole lot of sense, but that's okay. It's saying, hey, I want to insert into, and I'll give you a constant string. Remember, this idea with constant is if I give you a reference, I promise not to change it. Because passing stuff by reference is efficient. If I have an entire string, I don't want to make a copy of it every time. Imagine like I wrote or I have a string in memory of the book of Moby Dick. I don't want to make a copy of Moby Dick just to give it to a function. Right? That'd be a big waste of memory. So I can pass it by reference. But if I had this little constant flag here, I'm saying, I promise I won't change it on you. But please give me the reference, right? Because I don't want to have to double this thing in memory here. So we can say, okay, now I can go and write these things. So what that lets you do is you can output to them, right? Using something here. So you can use this insertion operator here on other things that are not file streams and not the standard output. We'll come back to when we get to classes. I don't know why this is here. That's super weird. But sure. Yeah, why? Why? This is so out of order. Uh, sorry, I didn't write the book. So let's look at what labs we did. So did I turn on some of the labs for this one? I think I did, right? I didn't turn any of the labs. I'm sorry. Uh, these are all good. I should make these visible. Good practice, because files are tricky here. Files are tricky. Look at that, course grades. Look at that. Like, we're on the same thing here. All right. A thesaurus. That one's fun. All right. We okay with streams? We did some midterm review. We talked about streams. I'll do the solution for project 2. Seriously? Really? Can't open my file? Okay. It worked that time, I guess. Maybe it'll work that time. So, midterm 1025. If you want to come, great. Use the room. I don't plan to be here because I don't like watching people take tests. Is that okay? If you'd like me to come, I can. Like, I'll keep you company. I'll bring my coffee and I'll drink my coffee while I watch you. It's not awkward at all. When we come back next week, then we'll start on arrays and vectors in chapter 7, and we'll talk about our next project that uses arrays and vectors and files. Streams. It'll be awesome. It'll be a lot of fun. That'll be the last individual project, believe it or not. And then we get to objects and classes, and we start talking about our final project in November. And we have that up until the end of the semester. So we are almost done. Yeah. So if you'd like to work in pairs, you may for the final project. I would encourage people to work in pairs because I think you'll get a better project, a better result out of it. And because I let people pick their own partners, usually they're not upset with me. They're like, you don't pick a partner who sucks. Most people don't. So great. If you want to work individually, that's cool too. I know schedules are a little hard sometimes and whatnot. So hopefully we've got some time to work on it. We don't have to go super deep into pointers because you'll cover this as a deep dive in this topic in the next class in CIS 200, which registration is coming up, by the way. Please schedule your counseling visits or advising visits to get the hold off your account. We looked at there's only 4 sections of 200 on the plan right now. 2 of them are at 9:30 in the morning. I don't know why. I didn't write the schedule. I'm sorry. It's not, they don't ask for my input. One is at 11 and one is at 6 p.m. So you want to make sure you don't have a hold on your account so you can get the one of those times that you prefer, right? Before the others.
Teaching them.
Not currently planned to. No, we've got other folks teaching most of them. So, I mean, I can't even teach the evening one anyway. So that's the only one that I don't have someone assigned yet. Yeah. So yeah, we're coming up near the end already. So in terms of new topics, right, we've got arrays and vectors, chapter 7, objects and classes, chapter 8, pointers, chapter 9. So 3 chapters left. We've gone through 6. Folks are doing great. So I got to get your stuff entered here. I'm sorry. You've done the self-assessments. You're doing great on those. So most of the time you just get your score because you folks are pretty good at assessing themselves here. If you gave yourself 100% and you only had half the code, obviously you're not going to get your score. Like if you lied about it, you won't get the score, and then I'll be upset with you. But most of the time you'll be like, oh yeah, I got most of it here, or I got some of it here, and it's all good. Okay. All right. So I will see you for lab, and then a week after, next Monday for class. All right, folks, take care.